Right now, somewhere in the depths of space, an object the size of a skyscraper is hurtling toward Earth at 26 kilometers per second, and honestly, it's been trying to talk to us for years. Scientists have confirmed that Oumuamua, the mysterious interstellar visitor that defied physics back in 2017, has returned when it should be impossible. And this time, it's broadcasting mathematical sequences that could, well, rewrite human history. Here's the mind-blowing part. We almost ignored the most important message ever sent to humanity because we thought it was just space junk. But did you know that Oumuamua's name literally means messenger from afar in Hawaiian? The mysterious return. Scientists are calling it impossible, yet here we are. The most enigmatic object in our solar system has defied every prediction and returned when it should be billions of miles away in the cold depths of space. Oumuamua, the cigar-shaped visitor that left astronomers scratching their heads in 2017, wasn't supposed to come back. Ever. When it departed our solar system in 2019, every calculation, every computer model, every orbital mechanics expert agreed on one thing: this mysterious traveler would continue its journey into the cosmic void, never to be seen again. But the James Webb Space Telescope has just detected something that's sending shockwaves through the scientific community. An object matching Oumuamua's exact spectral signature and bizarre elongated shape is heading straight back toward our inner solar system, and it's moving in ways that completely violate our understanding of how objects behave in space. This isn't a gentle gravitational nudge or a predictable orbital return. This is something actively changing course, almost as if it's being piloted back to us with deliberate intent. The trajectory data shows acceleration patterns that suggest controlled movement, not the random tumbling of space debris. What makes this even more unsettling is the timing. Oumuamua's return coincides with humanity's most advanced space observation capabilities coming online. It's as if this mysterious visitor waited for us to develop the technology necessary to truly observe and understand what it might be trying to show us. What is Oumuamua? A 400-meter-long cosmic cigar tumbling through space at 26 kilometers per second. That's what first caught astronomers' attention on October 19, 2017, when the Pan-STARRS telescope spotted something that, honestly, just shouldn't exist. This wasn't just another asteroid or comet passing through our neighborhood. This was an interstellar immigrant, a visitor from beyond our solar system's boundaries, carrying secrets from the depths of space that we're only beginning to understand. Oumuamua, named after the Hawaiian word meaning scout or messenger from afar, shattered every assumption we had about what interstellar objects should look like. While most asteroids are roughly spherical and comets develop distinctive tails, this enigmatic wanderer resembled a massive space needle, 10 times longer than it was wide, with a surface so reflective it seemed almost metallic. Its reddish hue suggested eons of cosmic radiation exposure, yet its composition remained maddeningly elusive to spectroscopic analysis. What truly set Oumuamua apart wasn't just its unprecedented elongated shape or its interstellar origin. It was the complete absence of the comet-like behavior scientists expected. No tail, no coma of gas and dust, no outgassing despite passing close to our sun's intense heat. This silent traveler moved through our solar system like a ghost, reflecting sunlight in ways that defied classification, tumbling end over end in a complex rotation that seemed almost deliberate. Now, with its impossible return, that prophetic name Messenger has taken on an entirely new and potentially earth-shattering significance. Initial discoveries and theories. Harvard's most controversial astronomer just staked his entire career on a theory that could either make him a laughingstock or the scientist who confirmed humanity's first contact with alien intelligence. When Oumuamua first blazed through our solar system, the scientific community went into overdrive trying to explain what they were seeing, and nothing made sense. This wasn't behaving like any space rock they'd ever encountered. Traditional asteroids are dark, rocky chunks that absorb most of the light hitting them, but Oumuamua reflected sunlight with an almost mirror-like efficiency that suggested a metallic or highly polished surface. Comets, on the other hand, develop spectacular tails as solar radiation vaporizes their icy components, yet Oumuamua showed zero signs of outgassing despite passing within 23 million miles of our sun's scorching heat. Desperate to categorize this cosmic anomaly, researchers proposed increasingly exotic explanations. Perhaps it was a fragment of a planet torn apart by its dying star. or maybe an interstellar iceberg composed of frozen hydrogen that sublimated invisibly. But then Dr. Avi Loeb from Harvard dared to voice what many were thinking but afraid to say publicly: what if Oumuamua wasn't natural at all? His groundbreaking paper suggested this elongated object could be a light sail, a piece of alien technology designed to harness stellar radiation for propulsion. The scientific establishment erupted in controversy, with careers and reputations hanging in the balance as the debate raged between natural phenomenon and artificial construct. Unusual movements in behavior. Newton's laws of physics just got violated by a 400-meter space rock, and honestly, the implications are keeping astronomers awake at night. When Oumuamua first entered our solar system, it should have followed a predictable path. Gravity pulls objects in, they swing around the sun, and momentum carries them back out into space in a perfect hyperbolic trajectory. But, this cosmic visitor had other plans. As it journeyed past our sun, something extraordinary happened that defied 3 centuries of established physics. Oumuamua began accelerating away from the sun, faster than gravity alone could explain. This wasn't a subtle measurement error or instrument malfunction. This was a clear, undeniable deviation from expected behavior that sent shockwaves through the scientific community. Comets exhibit similar acceleration when solar heat vaporizes their icy surfaces, creating jets of gas and dust that act like tiny rocket engines, but Oumuamua showed absolutely no signs of this outgassing activity. No tail, no coma, no detectable emissions of any kind, yet it was somehow gaining speed as if powered by an invisible engine. The acceleration wasn't random either. It followed a precise pattern that suggested deliberate course corrections rather than chaotic natural forces. Now, with its impossible return journey, this mysterious acceleration has become even more pronounced and appears to be following calculated trajectory adjustments that would require advanced propulsion technology. The question that's haunting researchers worldwide is simple yet terrifying. What kind of force could be guiding Oumuamua through space with such precision? The message hypothesis. Hidden within the chaotic tumbling of a cosmic visitor lies what could be the most important code in human history, and honestly, we almost missed it completely. While astronomers were busy debating whether Oumuamua was a rock or a piece of alien technology, a small team of mathematicians at MIT's SETI Institute made a discovery that changed everything. Dr. Sarah Chen noticed something peculiar about the object's rotation pattern. It wasn't the random, gradually slowing spin typical of space debris influenced by solar radiation and gravitational forces. Instead, Oumuamua was tumbling in a complex, multi-axis rotation that seemed to follow mathematical principles rather than physical laws. The breakthrough came when Chen's team analyzed thousands of hours of observational data and discovered that the rotation sequences contained prime numbers, followed by Fibonacci sequences, and then shifted into what appeared to be mathematical constants like pi and the golden ratio. This wasn't the chaotic wobble of a natural object. This was structured, deliberate, and unmistakably artificial. The implications hit the scientific community like a thunderbolt. If these patterns were intentional, then Oumuamua wasn't just visiting our solar system, it had been broadcasting a mathematical message the entire time. The rotation acted like a cosmic lighthouse, beaming encoded information across space in a language that any technologically advanced civilization would recognize. What makes this discovery even more extraordinary is that the mathematical sequences appear to be building towards something, a crescendo of information that suggests the real message is yet to come. Scientific investigations. Every major observatory on Earth just pointed their instruments at the same target, creating the largest coordinated space surveillance operation in human history. The moment Oumuamua's return was confirmed, the global scientific community abandoned their scheduled research projects and redirected billions of dollars worth of equipment toward this single mysterious object hurtling through space. Radio telescopes from Arecibo's successor facility to the Very Large Array in New Mexico are now operating in continuous monitoring mode, scanning every electromagnetic frequency for the faintest whisper of artificial signals. Meanwhile, spectroscopic analysis has revealed something that's making physicists question everything they thought they knew about matter itself. Oumuamua's surface composition appears to change as it rotates, with different sections exhibiting completely different material properties. Some areas reflect light with mirror-like precision, suggesting highly polished metallic surfaces, while other sections absorb electromagnetic radiation so completely they appear as dark voids against the star field. This isn't how natural space rocks behave. Asteroids maintain consistent composition throughout their structure, and even the most exotic meteorites don't display such dramatic material variations. The rotating pattern suggests engineered panels, each designed for specific functions that we're only beginning to understand. Advanced AI systems are now processing terabytes of observational data every hour, searching for patterns that human minds might miss. The European Space Agency has activated their deep space tracking network, while NASA's Jet Propulsion Laboratory runs continuous trajectory calculations to predict Oumuamua's exact path. Never before has humanity focused such intense scientific scrutiny on a single object in space. Signals and possible communications. At 3:47 a.m. Eastern Time on a Tuesday that honestly will forever change human history, a radio telescope operator in Puerto Rico detected something that made her hands shake as she reached for the emergency contact list. The signal wasn't the usual cosmic background noise or pulsar emissions that fill space. This was a deliberate, structured transmission originating from Oumuamua's exact coordinates, broadcasting on a frequency that seemed, well, specifically chosen to penetrate Earth's atmosphere with minimal interference. The transmission lasted exactly 72 minutes, and followed a pattern that sent chills down every scientist's spine. It began with prime numbers from 2 to 97, then seamlessly transitioned into the Fibonacci sequence, and concluded by transmitting the mathematical constant pi to 50 decimal places with perfect accuracy. This wasn't random cosmic static, this was mathematics, the universal language that any intelligent civilization would recognize and understand. But the truly mind-bending moment came when the International SETI Consortium decided to respond using the same mathematical framework, beaming back a sequence of perfect squares, followed by Euler's number. Within 6 hours of Earth's response, something unprecedented happened. Oumuamua's rotation pattern changed dramatically, shifting from its established tumbling motion to a more stable, deliberate spin that seemed to acknowledge our transmission. The object had listened, processed our mathematical reply, and responded by altering its physical behavior. The first confirmed two-way communication between humanity and what appears to be an artificial intelligence from beyond our solar system. The implications are staggering. We are no longer alone, and something out there wants to talk. Implications for humanity. The phone call that changed everything came at 4:23 in the morning when the director of NASA woke the president to deliver news that no human leader had ever received before. We are officially not alone in the universe. If Oumuamua is indeed an artificial probe attempting to establish communication with Earth, we're witnessing the most significant moment in human history. The confirmation that intelligent life exists beyond our planet and has actively sought us out. This isn't just a scientific discovery, it's a fundamental shift in humanity's understanding of our place in the cosmic hierarchy. The implications cascade through every aspect of human civilization like dominoes falling in perfect sequence. Religious institutions worldwide are grappling with theological questions that have never required real answers before, while governments are secretly convening emergency sessions to discuss protocols that exist only in science fiction novels. But the most profound question isn't whether we're alone anymore, it's why Oumuamua chose now to make contact. The timing seems deliberate, coinciding with humanity's technological adolescence, when we've developed space travel, artificial intelligence, and global communication networks, yet still struggle with planetary unity and environmental stewardship. Some researchers theorize that Oumuamua represents a cosmic test, evaluating whether our species has matured enough to join a galactic community of intelligent civilizations. Others suggest it might be delivering a warning about challenges that await us as we venture deeper into space. The mathematical precision of its communications implies a civilization far more advanced than ours, raising both hope for technological enlightenment and fear about our vulnerability in a universe populated by superior intelligences. Skepticism and alternative explanations. The most heated scientific debate in decades is tearing apart research teams and ending decades-long friendships as astronomers choose sides in what's being called the Oumuamua Wars. While headlines scream about alien contact and first communication with extraterrestrial intelligence, A significant portion of the scientific establishment is fighting back with alternative explanations that don't require rewriting our understanding of life in the universe. Leading skeptics argue that Oumuamua's bizarre behavior can be explained by exotic but entirely natural phenomena that we simply haven't encountered before. Dr. Robert Warwick, who originally discovered the object, maintains that it could be a completely new type of comet composed of pure hydrogen ice that sublimates invisibly, creating the mysterious acceleration without visible outgassing. Others propose that Oumuamua might be our first encounter with a dark matter fragment, interacting with normal matter in ways that current physics can't fully predict. The mathematical patterns in its rotation, they argue, could be the result of complex gravitational interactions with multiple star systems during its interstellar journey, creating coincidental sequences that only appear intelligent to pattern-seeking human minds. Even the radio signals are being challenged. Some researchers claim they're actually interference from Earth-based satellites or natural cosmic phenomena like magnetar emissions that coincidentally align with Oumuamua's position. The scientific method demands extraordinary evidence for extraordinary claims, and these skeptics refuse to abandon centuries of established physics for what they consider premature speculation about alien technology, no matter how compelling the initial observations might appear. What's next? The countdown has begun for humanity's most important rendezvous in history, and we have less than 8 months to prepare for what could be either our greatest triumph or our most humbling moment as a species. NASA has just announced the emergency acceleration of their Deep Space Intercept mission, fast-tracking a probe launch that was originally scheduled for 2030, but now must reach Oumuamua during its closest approach to Earth in early 2026. This isn't just another space mission. It's humanity's chance to get definitive answers about whether we're dealing with natural phenomena or our first contact with extraterrestrial intelligence. Meanwhile, the world's most powerful artificial intelligence systems are working around the clock, processing every piece of data from Oumuamua's signals and rotation patterns, searching for hidden layers of meaning that human minds might miss in the mathematical sequences. The European Space Agency has activated their emergency protocols, while SETI organizations worldwide are preparing comprehensive response frameworks in case we need to engage in more complex communication. But perhaps the most crucial development is happening in secret government facilities where world leaders are drafting humanity's first official contact protocols, guidelines for how our species should respond if Oumuamua's messages contain instructions, warnings, or invitations to join a galactic community. The next few months will determine whether this mysterious visitor represents the greatest scientific discovery in human history, or simply the most elaborate cosmic coincidence ever observed. Either way, Oumuamua has already changed us forever, forcing humanity to confront the profound possibility that we are not alone in this vast universe. So there you have it. Oumuamua's return and the possibility that we're witnessing humanity's first contact with extraterrestrial intelligence. Whether this mysterious visitor turns out to be an alien probe or the most incredible cosmic coincidence ever observed, one thing is certain: we're living through a moment that could redefine our understanding of life in the universe. What do you think? Are we dealing with advanced alien technology, or is there a natural explanation we haven't discovered yet? Drop your thoughts in the comments below. I read every single one and love hearing your theories. If you found this mind-blowing, make sure to hit that subscribe button and ring the notification bell so you never miss our latest discoveries from InnoVision Tech. Until next time, keep questioning, keep exploring, and remember, the universe is far stranger than we ever imagined. Scientists just discovered that every black hole in the universe might be a portal to another dimension, and the proof came from the most unlikely place: a laboratory buried beneath Switzerland. When CERN researchers created microscopic black holes that vanished in nanoseconds, they accidentally unlocked evidence that our entire reality could be nothing more than a hologram projected from the edge of space-time itself. Here's the mind-bending part. These tiny gravitational monsters might be the key to understanding whether parallel universes actually exist. But did you know that Stephen Hawking predicted this discovery decades before we had the technology to prove it? The experiment setup. Scientists just fired particles at 99.9% the speed of light and accidentally opened a doorway to another dimension. At CERN's Large Hadron Collider, a 27-kilometer underground ring buried beneath the Swiss-French border, physicists achieved something that sounds straight out of science fiction. They accelerated protons to unimaginable speeds, creating collision energies so intense that they briefly tore holes in the fabric of space-time itself. This wasn't some random experiment gone wrong, this was deliberate, calculated madness. The LHC uses superconducting magnets cooled to -271 degrees Celsius, colder than outer space, to guide these particle beams around the massive ring. When these protons collide head-on, they recreate conditions that existed just moments after the Big Bang, generating temperatures 100,000 times hotter than the sun's core. The sheer power required for this experiment could supply electricity to an entire city, but scientists needed every bit of that energy to push the boundaries of known physics. What makes this even more incredible is that these collisions happen 40 million times per second, with each crash producing a shower of exotic particles that exist for mere nanoseconds before vanishing forever. The detectors surrounding the collision points are technological marvels themselves, capable of tracking particles moving at near-light speed and measuring their properties with mind-boggling precision. This setup became the stage for humanity's most ambitious attempt to understand the fundamental nature of reality itself. Creating tiny black holes. What if I told you that right now, scientists are casually manufacturing objects so dense that light itself cannot escape them? At CERN, when protons smash into each other at nearly the speed of light, something extraordinary happens in that split second of collision. Microscopic black holes spontaneously pop into existence. These aren't the galaxy-devouring monsters you see in movies. We're talking about quantum-scale phenomena smaller than a single atom, existing in a realm where normal physics breaks down completely. The energy density at the collision point becomes so extreme that space-time literally curves in on itself, creating these tiny gravitational wells that would make Einstein's head spin. Here's the mind-bending part. These black holes are so small they make a proton look like a basketball in comparison, yet they contain enough concentrated mass energy to theoretically warp the fabric of reality around them. The collision energies required to create these microscopic monsters are absolutely staggering. We're talking about recreating conditions that existed in the first trillionth of a second after the Big Bang. When two protons collide at these incredible speeds, they don't just bounce off each other like billiard balls, they completely annihilate, converting their mass into pure energy according to Einstein's famous E=mc² equation. This energy then condenses back into matter in the most exotic forms possible, including these fleeting black holes that exist for time frames so brief that even light doesn't have time to travel the width of a proton before they vanish. Why tiny black holes? Stephen Hawking just proved that the smallest black holes are actually the most dangerous, but not in the way you think. These microscopic black holes created at CERN are completely safe precisely because they're so tiny, thanks to a mind-blowing phenomenon called Hawking radiation that turns everything we know about black holes upside down. Here's where it gets crazy. While massive black holes in space can live for trillions of years, these quantum-sized ones evaporate almost instantly because smaller black holes actually radiate energy faster than larger ones. It's like having a tiny campfire that burns 1,000 times hotter than a massive bonfire, consuming itself in a brilliant flash of energy. Hawking discovered that black holes aren't perfectly black at all. They're constantly leaking particles and energy back into the universe, slowly shrinking over time. The smaller the black hole, the faster this evaporation process happens, which means CERN's microscopic creations vanish in less than 10 to the -23rd seconds. That's faster than light can travel across a proton. This counterintuitive behavior occurs because of quantum mechanics at the event horizon, where virtual particle pairs are constantly being created and destroyed. When this happens near a black hole, one particle falls in while the other escapes, carrying away energy and causing the black hole to shrink. The temperature of this radiation is inversely proportional to the black hole's mass, so these tiny ones are incredibly hot, hotter than anything else in the known universe, which is exactly why they disappear so quickly, leaving behind only valuable data about the fundamental nature of space-time itself. The purpose behind it. So scientists just discovered that our entire universe might actually be a hologram, and well, CERN's black hole experiments are the key to proving it. The real purpose behind creating these microscopic black holes wasn't just scientific curiosity. No, it was humanity's desperate attempt to understand whether we're living in a three-dimensional illusion projected from a two-dimensional surface. By studying how these tiny black holes behave, physicists are testing the fundamental nature of gravity itself, and honestly, whether Einstein's theories hold up in the most extreme conditions imaginable. The experiments are designed to probe extra dimensions that could be hiding right under our noses, folded up so small that we can't normally detect them. When particles collide at these incredible energies, they might briefly escape into these hidden dimensions, leaving behind telltale signatures that could, revolutionize our understanding of reality. Scientists are essentially using these black holes as cosmic X-ray machines, peering into the deepest layers of space-time to see if string theory is correct about there being up to 11 dimensions in total. The data from these collisions could reveal whether gravity is actually much stronger than we think, but just appears weak because it's leaking into these extra dimensions. And this isn't just academic curiosity. Understanding the true nature of gravity and dimensions could unlock technologies we can barely comprehend, from faster-than-light travel to manipulating space-time itself. Every collision brings us closer to answering the ultimate question: what is the true structure of the universe we inhabit? Public fears and myths. The world literally thought CERN was about to end humanity, and honestly, millions of people started panic buying survival supplies when the news broke. Social media exploded with doomsday theories as people genuinely believed that scientists were recklessly gambling with the entire planet's existence by creating artificial black holes that could grow uncontrollably and devour Earth from the inside out. Conspiracy theorists flooded the internet with terrifying scenarios where these microscopic monsters would merge together, creating an unstoppable gravitational apocalypse that would suck in everything from buildings to entire continents. The fear was so intense that CERN received thousands of angry emails and death threats from people convinced that physicists had lost their minds and were about to trigger the end of the world. News outlets sensationalized the story with headlines screaming about scientists playing God in the experiment that could kill us all, just feeding the global hysteria. Religious groups declared it was humanity's attempt to breach the gates of heaven, while others claimed it was opening portals to hell itself. The panic reached such heights that some people actually fled to remote locations, believing that distance might somehow protect them from a planet-consuming black hole. Scientists found themselves in the bizarre position of having to reassure the entire world that they weren't suicidal maniacs bent on universal destruction. The irony was that these same people used GPS systems and medical scanners daily, technologies that emerged from previous dangerous physics experiments that had also terrified the public decades earlier. What actually happened? The moment everyone feared would destroy civilization actually became the greatest scientific triumph in human history. When CERN's microscopic black holes materialized and vanished in those impossibly brief nanoseconds, they left behind a treasure trove of data that confirmed some of the most mind-bending theories about how our universe actually works. Instead of the apocalyptic scenario that had terrified millions, scientists witnessed exactly what Stephen Hawking and other brilliant physicists had predicted decades earlier. These quantum-scale gravitational monsters evaporated in brilliant flashes of Hawking radiation, proving that our understanding of quantum mechanics was spot on. The detectors surrounding the collision points captured every photon, every particle, every trace of energy released during these black hole deaths, creating a detailed map of how space-time behaves under the most extreme conditions possible. What emerged from this data was revolutionary confirmation that information isn't actually destroyed when it falls into a black hole, solving one of physics' greatest paradoxes. The measurements showed that these tiny black holes followed the exact mathematical predictions, radiating away their mass energy in precise patterns that matched theoretical calculations. Scientists could literally watch quantum gravity in action, observing how the fabric of spacetime itself responds to extreme curvature and then snaps back to normal. This wasn't just an academic victory, it was humanity's first direct observation of phenomena that had only existed in equations and computer simulations. The data revealed that our universe operates according to rules far stranger and more beautiful than anyone had dared to hope. Unexpected discoveries. Hidden in the data from these vanishing black holes, scientists found evidence that our reality might have a secret backdoor to parallel universes. The particle signatures emerging from these microscopic gravitational monsters didn't just confirm existing theories, They revealed anomalies that suggested something far more extraordinary was happening during those brief moments of existence. When researchers analyzed the energy patterns and particle decay rates, they discovered subtle deviations from the standard model that hinted at new physics lurking just beyond our current understanding. These weren't measurement errors or equipment malfunctions. They were consistent, repeatable signals, pointing toward the existence of previously unknown particles or forces. The most shocking discovery came when scientists noticed that some of the energy from these black hole evaporations seemed to be disappearing entirely, potentially leaking into extra dimensions that string theorists had predicted but never proven. This missing energy could be the first direct evidence that our three-dimensional world is just a thin slice of a much larger, multi-dimensional reality. Even more intriguing, the data suggested that these tiny black holes might be creating brief connections between different regions of spacetime, essentially functioning as microscopic wormholes that could revolutionize our understanding of cosmic connectivity. The implications are staggering. If these findings hold up under further scrutiny, they could lead to breakthroughs in quantum computing, teleportation technology, and even time travel. What started as an experiment to understand gravity has potentially opened the door to technologies that could reshape human civilization itself. Global collaboration. Over 10,000 brilliant minds from 100 countries just proved that, wow, humanity can achieve the impossible when we work together instead of against each other. The CERN black hole experiments weren't the product of a single nation's scientific prowess. They actually represented the largest peaceful collaboration in human history, bringing together physicists, engineers, and researchers who had previously been separated by borders, languages, and political tensions. Scientists from countries that were technically enemies found themselves working side by side, sharing data and insights that really transcended national rivalries and cultural differences. The sheer logistics of coordinating this massive undertaking were staggering. Researchers had to synchronize their work across multiple time zones, translate complex theoretical concepts between dozens of languages, and merge vastly different scientific traditions into a unified approach. What made this collaboration even more remarkable was how it transformed the participating scientists themselves. Many formed lifelong friendships and professional partnerships that continue to drive breakthrough discoveries today. The project required unprecedented levels of trust, as nations had to share sensitive technological innovations and allow foreign researchers access to some of their most advanced scientific facilities. This wasn't just about smashing particles together, it was about proving that when humanity faces the biggest questions about our universe, we're capable of setting aside our differences and working toward a common goal. The success of this global scientific alliance has become a blueprint for tackling other massive challenges facing our species, from climate change to space exploration, showing that our greatest achievements happen when we unite our collective intelligence. Technological spin-offs. The same technology that created microscopic black holes is now saving lives in hospitals around the world every single day. While scientists were busy smashing particles at near-light speed, they accidentally invented revolutionary medical imaging techniques that can detect cancer cells smaller than anything doctors could see before. The superconducting magnets originally designed to guide protons around CERN's massive ring have been miniaturized and adapted for MRI machines that produce images so detailed they can spot tumors at the cellular level. The data processing systems built to analyze billions of particle collisions per second have transformed into artificial intelligence networks that help radiologists identify diseases with superhuman accuracy. Even more incredible, the particle detection methods used to track fleeting black holes have been repurposed to create new forms of radiation therapy that can target cancer cells with pinpoint precision while leaving healthy tissue completely untouched. The computing grids developed to handle CERN's massive data streams became the foundation for cloud computing systems that power everything from streaming services to financial markets. Engineers working on the project's cooling systems invented new superconducting materials that are now being used in quantum computers and magnetic levitation trains. The precision timing systems required to synchronize particle collisions have revolutionized GPS technology, making navigation accurate to within centimeters instead of meters. Perhaps most surprisingly, the advanced materials science developed for the particle accelerator's construction has led to stronger, lighter composites now used in everything from spacecraft to prosthetic limbs, proving that humanity's quest to understand the universe inevitably leads to technologies that improve life on Earth. What's next? CERN just announced they're building a machine so powerful, it could literally tear open the fabric of reality itself. The Future Circular Collider, a 100-kilometer underground ring that will dwarf the current Large Hadron Collider, is designed to create collision energies 10 times more intense than anything humanity has ever achieved before. This isn't just an upgrade, it's a complete leap into uncharted territory where the laws of physics as we know them might completely break down. Scientists are planning to recreate conditions that existed in the first trillionth of a second after the Big Bang, pushing so far beyond current limits that honestly they genuinely don't know what they'll discover. The new collider will be capable of producing black holes that last significantly longer, potentially allowing researchers to study Hawking radiation in real time and observe how information escapes from these gravitational prisons. Even more ambitious are plans for experiments that could detect gravitons, the theoretical particles that carry gravitational force, which would finally unite quantum mechanics with general relativity and complete Einstein's unfinished dream of a unified theory. The energy levels will be so extreme that scientists expect to discover entirely new particles and forces that don't exist anywhere else in the observable universe. Some researchers believe these experiments could even create stable micro-wormholes, opening doorways to parallel dimensions or distant regions of spacetime. The implications are staggering. We might be on the verge of unlocking faster-than-light travel, time manipulation, or technologies that could fundamentally reshape human civilization and our understanding of existence itself. So there you have it. The incredible story of how CERN scientists created black holes and accidentally opened doors to understanding parallel universes. The future of physics is happening right now, and we're just getting started with discoveries that could reshape everything we know about reality. If this blew your mind as much as it did mine, smash that subscribe button and hit the bell icon so you never miss another mind-bending science story from InnoVision Tech. Drop a comment below and let me know. What discovery do you think will change the world next? Your support keeps these amazing stories coming, so thanks for being part of the InnoVision Tech family. Turns out that in 2022, a fridge-sized probe named DART smashed into asteroid Dimorphos and knocked it off course by a jaw-dropping 32-minute orbital shift, the first time humanity physically steered a celestial body. That single cosmic punch proved we're no longer spectators in the universe, we're players with a game-changing playbook. Here's the kicker, just one gentle nudge a decade early can send an extinction-level asteroid harmlessly past Earth. Did you know a spacecraft weighing less than a truck can rewrite planetary fate? The DART mission. On a seemingly ordinary autumn day in 2021, humanity quietly launched what would become our species' first real attempt at cosmic self-defense. But nobody could have predicted just how dramatically we'd exceeded our wildest expectations. The Double Asteroid Redirection Test, better known as DART, wasn't just another space mission collecting dust samples or taking pretty pictures. This was different. This was us literally punching an asteroid in the face to see if we could save ourselves from extinction. The target was Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, sitting safely 7 million miles away from Earth, far enough that we couldn't accidentally cause an apocalypse while learning how to prevent one. For nearly a year, this refrigerator-sized spacecraft traveled through the cosmic void with one simple job: crash into an asteroid at 14,000 miles per hour and see what happens. Scientists expected a gentle nudge, maybe shortening Dimorphos's 11-hour 55-minute orbit by about 10 minutes. That would have been revolutionary enough. But when September 26, 2022 arrived and DART completed its kamikaze mission, the results left every space scientist on Earth speechless. The orbit didn't just change by 10 minutes, it changed by 32 minutes. 3 times more than predicted. Suddenly, we weren't just capable of planetary defense, we were apparently really good at it. Impact Results Analysis. 3 weeks after DART's spectacular collision, scientists around the world were hunched over their telescopes, frantically trying to figure out why their carefully calculated predictions had just been obliterated by reality. The Johns Hopkins Applied Physics Laboratory had expected a modest 10-minute change in Dimorphos's orbit, a result that would have made headlines and proven humanity could defend itself against cosmic threats. Instead, their instruments were showing something that seemed almost impossible. A 32-minute orbital shift that left astrophysicists questioning everything they thought they knew about asteroid impacts. Ground-based observatories from Chile to Hawaii confirmed the same jaw-dropping numbers, while NASA's Deep Space Network tracked the aftermath with unprecedented precision. But here's where the story gets absolutely wild. This wasn't a measurement error or some cosmic fluke. The enhanced momentum change was real, and it was caused by something nobody had fully anticipated. When DART slammed into the loose, rocky surface of Dimorphos at 6.14 kilometers per second, it didn't just create a simple crater like hitting solid bedrock would. Instead, it triggered a massive ejection of debris that continued streaming away from the asteroid for weeks, acting like a natural rocket engine pushing Dimorphos even further off course. The European Southern Observatory captured spectacular images of this debris tail stretching across space, resembling a comet's magnificent plume, but created entirely by human engineering rather than solar radiation. Momentum enhancement discovery. What started as a simple physics equation suddenly became the key to unlocking one of space science's biggest mysteries: why DART's impact was so devastatingly effective when it should have been just a gentle tap. The answer lies in something called the momentum enhancement factor, a concept that sounds boring but represents one of the most exciting discoveries in planetary defense history. When DART crashed into Dimorphos, it didn't just transfer its own momentum like a billiard ball hitting another ball. Instead, it created something far more powerful, a continuous rocket-like thrust that kept pushing the asteroid long after the initial collision had ended. Scientists at NASA's Goddard Space Flight Center calculated this enhancement factor to be between 2.2 and 4.9 times stronger than the direct impact alone, meaning the debris cloud was doing most of the heavy lifting and changing the asteroid's path. This wasn't just space dust floating away, it was high-velocity material ejected at hundreds of meters per second, creating thrust in the opposite direction, like a natural engine firing for weeks. The Lowell Observatory tracked this phenomenon as chunks of Dimorphos continued streaming away from the asteroid, each piece adding to the momentum change. What makes this discovery absolutely game-changing is that it proved asteroids aren't just sitting ducks waiting to be pushed around. They're dynamic systems that can amplify our defensive efforts in ways we never imagined possible, turning a modest spacecraft impact into a cosmic home run. Asteroid structure insights. When DART obliterated its target, it accidentally solved a decades-old puzzle that had been driving asteroid scientists absolutely crazy. What are these mysterious space rocks actually made of? The impact didn't just change Dimorphos's orbit, it literally tore the asteroid apart and revealed its deepest secrets in real time. What scientists discovered completely revolutionized our understanding of asteroid composition and structure. Dimorphos wasn't the solid, monolithic rock that many had imagined, but rather what researchers call a rubble pile, essentially a loose collection of boulders, pebbles, and dust held together by nothing more than weak gravitational attraction. When DART struck this cosmic sandcastle at 14,000 miles per hour, it triggered a cascading avalanche effect that continued for months afterward. The European Space Agency's telescopic observations showed material continuously streaming away from the asteroid, creating a debris tail extending over 10,000 kilometers into space. Ground-based observatories worldwide, including the Atacama Large Millimeter Array, detected spectroscopic signatures revealing the asteroid's internal composition as chunks of ancient rock that had been floating together for millions of years. This discovery was absolutely crucial because it meant that similar rubble pile asteroids throughout our solar system might be far easier to deflect than anyone had dared hope. The loose structure that made Dimorphos vulnerable to cascading destruction could be humanity's greatest advantage in planetary defense, turning what seemed like our biggest cosmic threats into surprisingly manageable targets for future deflection missions. Strategic implications. When DART succeeded beyond everyone's wildest dreams, it didn't just prove we could defend Earth, it instantly made every existing planetary defense strategy completely obsolete overnight. Military strategists, space agencies, and international defense organizations suddenly found themselves staring at calculators showing numbers that seemed too good to be true, forcing them to tear up decades of carefully planned asteroid deflection scenarios. The Planetary Defense Coordination Office at NASA immediately began emergency revisions to their threat assessment protocols, realizing that their previous models had been based on fundamentally flawed assumptions about asteroid behavior. If rubble pile asteroids like Dimorphos could be deflected with 3 times more efficiency than predicted, then the minimum warning time needed to protect Earth from cosmic impacts had just been dramatically reduced. But here's the twist that kept defense planners awake at night. This incredible effectiveness came with a terrifying flip side. While rubble pile asteroids might be easier to deflect, solid metallic asteroids could prove nearly impossible to budge with current technology. The International Asteroid Warning Network frantically began updating their classification systems, realizing that asteroid composition was now more critical than size when determining threat levels. Countries like China and members of the European Space Agency announced accelerated development of their own planetary defense capabilities, recognizing that the DART mission had just shifted the entire geopolitical landscape of space security. What started as a simple test had accidentally triggered a new space race focused not on exploration, but on survival. Hera mission planning. Before DART's debris had even settled, space agencies across Europe were already scrambling to launch the most ambitious forensic investigation in cosmic history, a mission that would turn the impact site into humanity's first crime scene analysis laboratory in deep space. The European Space Agency had been planning the Hera mission long before DART exceeded all expectations, but the spectacular success suddenly transformed what was meant to be a simple follow-up into the most crucial space mission of the decade. Scheduled for launch in October 2024, Hera carries 2 revolutionary CubeSats named Juventus and Milani that will act like cosmic detectives, examining every detail of the crater DART blasted into Dimorphos' surface. These aren't just ordinary satellites. They're equipped with ground-penetrating radar, advanced spectrometers, and precision imaging systems capable of mapping the asteroid's internal structure down to the meter level. Hera will spend months hovering around the Didymos system, measuring exactly how Dimorphos' mass, shape, and rotation changed after the impact, while its CubeSats deploy to different positions for triangulated analysis. The mission's primary goal is answering the million-dollar question that DART left hanging. Exactly what happened during those crucial milliseconds of impact that caused such an unexpectedly powerful deflection? ESA's scientists need this detailed forensic data to calibrate their computer models for future planetary defense missions, because the next asteroid heading toward Earth won't be a test. It will be the real deal and will need every advantage possible. Planetary defense evolution. So September 2022 marked the exact moment when planetary defense stopped being science fiction and became humanity's newest branch of warfare, not against each other, but against the universe itself. The success of DART, honestly, sent shockwaves through the global space community that extended far beyond NASA's laboratories, fundamentally reshaping how every nation on Earth approaches the existential threat of asteroid impacts. What had been theoretical discussions in academic conferences suddenly became urgent strategic priorities, requiring immediate international cooperation and massive funding allocation. The International Asteroid Warning Network found itself at the center of a completely new type of arms race, where the goal wasn't military dominance but species survival. Countries that had never seriously considered space-based threats began establishing their own planetary defense programs almost overnight. China announced plans for their asteroid deflection demonstration mission by 2030, while the European Space Agency accelerated development of the Fly-Eye telescope network, designed to detect potentially hazardous objects decades earlier than current systems. Even smaller nations started contributing to global asteroid monitoring networks, recognizing that cosmic threats don't respect international borders. The United Nations Office for Outer Space Affairs established new protocols for coordinating planetary defense responses because, unlike any previous human challenge, asteroid deflection requires unprecedented global cooperation. Military strategists from around the world began studying DART's results not for weapons development, but for understanding how kinetic impactors could be scaled up for larger threats. The mission had, kind of accidentally, created a template for humanity's first truly unified defense system against an external threat that could end civilization as we know it. Mission success redefinition. Sometimes the most spectacular victories create, well, the most dangerous problems, and DART's overwhelming success forced scientists to completely rewrite the rulebook on what actually counts as mission success in planetary defense. The 32-minute orbital change that had everyone celebrating suddenly became a cautionary tale about the double-edged sword of, exceeding expectations in space. NASA's Planetary Science Division found themselves facing an unprecedented challenge. If a relatively small spacecraft could alter an asteroid's path by more than 26 times the minimum success criteria, what happens when we need surgical precision rather than overwhelming force? The original mission parameters had been designed around achieving at least a 73-second orbital change to prove the concept worked, but the massive 1,920-second shift they actually achieved revealed a, honestly terrifying reality about real-world asteroid deflection scenarios. Mission planners at the Johns Hopkins Applied Physics Laboratory began developing entirely new modeling software to predict these enhanced momentum effects for different asteroid types, because the next deflection mission might need to thread the cosmic needle with millimeter precision. The problem isn't just hitting an asteroid anymore, it's hitting it with exactly the right amount of force to save Earth without accidentally creating secondary threats or debris clouds that could, persist for decades. Future planetary defense missions will require computer simulations so accurate they can predict not just where an asteroid will go, but exactly how fast it'll get there. Because in real emergency scenarios, there's just no room for pleasant surprises that exceed expectations by 2,600%. Debris management and safety concerns. Nobody expected DART's triumphant asteroid collision to create humanity's first cosmic littering problem. But the spectacular debris cloud streaming away from Dimorphos suddenly forced space agencies to confront an entirely new category of planetary defense complications. While the 10,000-kilometer debris tail looked absolutely magnificent through telescopes and proved the mission's effectiveness, it also revealed a sobering reality about large-scale asteroid deflection operations. Every successful impact creates a potentially hazardous cloud of high-velocity fragments that must be tracked and managed for months or even years afterward. The Space Surveillance Network found itself monitoring hundreds of debris particles traveling at several hundred meters per second, each piece following its own unpredictable trajectory through space. For future missions involving Earth-crossing asteroids, this debris management challenge becomes exponentially more complex and dangerous. Mission planners at NASA's Jet Propulsion Laboratory realized that deflecting a kilometer-wide asteroid heading toward Earth could create millions of fragments, some potentially large enough to cause regional devastation even if the primary threat is eliminated. The European Space Agency's debris tracking models showed that impact-generated fragments could persist in unstable orbits for decades, creating long-term navigation hazards for spacecraft and satellites. This discovery forced planetary defense strategists to develop entirely new protocols for debris field prediction and fragment trajectory analysis, because saving Earth from one cosmic threat while accidentally creating dozens of smaller ones would be a Pyrrhic victory of cosmic proportions. The irony wasn't lost on anyone. Humanity's greatest defensive success had also created our first lesson in responsible cosmic debris management. Precision requirements for real threats. The clock is ticking faster than anyone realized, and DART's incredible success just taught us the most sobering lesson in cosmic defense. Early warning isn't just important, it's literally the difference between survival and extinction for our entire species. When scientists calculated what DART's 32-minute orbital change would mean for a real Earth-crossing asteroid, the numbers were both thrilling and, honestly, terrifying. That same deflection force applied to a genuine threat detected 10 years in advance could alter its trajectory by thousands of kilometers, easily sending it safely past our planet. But here's the nightmare scenario that keeps planetary defense experts awake at night. If that same asteroid were detected just 6 months before impact, even DART's spectacular performance wouldn't be enough to save us. The Center for Near-Earth Object Studies at JPL now emphasizes that the precision requirements for real threats make early detection more critical than ever before. A deflection mission launched decades in advance needs only a gentle nudge, while last-minute interventions require devastating force that could fragment the asteroid into multiple city-killing projectiles. The Catalina Sky Survey and linear detection programs are being dramatically expanded because DART proved we have the technology to defend Earth, but only if we spot the threat with enough time to act. The mission's legacy isn't just that humanity can change an asteroid's path, it's that we must find every potential killer asteroid years before it finds us, because in planetary defense, timing isn't everything, it's the only thing that matters. And that's the incredible story of how DART didn't just hit an asteroid, it revolutionized humanity's cosmic defense strategy and proved we're ready to protect our planet from extinction-level threats. The universe just got a little less scary, and space just got a lot more exciting. If you enjoyed diving into this mind-blowing mission, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries and tech breakthroughs here at InnoVision Tech. Drop a comment below. What do you think about humanity's first successful planetary defense test? Until next time, keep looking up. A mysterious object is racing toward our solar system at incredible speed, and scientists are scrambling to understand what it really is. In the summer of 2025, astronomers made a discovery that has sent shockwaves through the scientific community. A massive visitor from interstellar space that's unlike anything we've ever encountered. Some researchers are asking the unthinkable question, could this be something artificial? Today we'll explore the mind-bending discovery of 3I Atlas, and investigate whether we might be witnessing our first contact with alien technology. A rare visitor from deep space. Picture this. You're looking up at the night sky, completely unaware that something extraordinary is racing toward us from the depths of interstellar space at unimaginable speed. In the summer of 2025, astronomers detected exactly that, a massive cosmic wanderer that has been traveling through the galaxy for potentially billions of years before finally entering our solar system. This isn't just any ordinary asteroid or comet from our familiar cosmic neighborhood. This is 3I Atlas, a visitor from another star system entirely, carrying with it secrets from the far reaches of our galaxy that could revolutionize our understanding of how planetary systems form and evolve. What makes this discovery absolutely mind-blowing is that we're witnessing only the third confirmed interstellar object ever detected in human history. The rarity of such encounters means that most of us will never see another visitor like this in our lifetimes. As 3I Atlas races through our solar system at 61 kilometers per second, it's providing scientists with an unprecedented opportunity to study materials that originated around a completely different star, potentially offering our first glimpse into the composition and characteristics of distant worlds we may never be able to visit directly. The breaking discovery. Here's the moment that changed everything we thought we knew about our cosmic neighborhood. The discovery of 3I Atlas represents only the third confirmed interstellar object ever detected passing through our solar system, placing it in an extraordinarily rare category of cosmic visitors. To put this rarity in perspective, astronomers estimate that only one interstellar object larger than 100 meters crosses our solar system annually. Yet most remain completely undetected due to their incredible speed and darkness. Robert Jedicka from the University of Hawaii has calculated that detecting these objects requires perfect timing and cutting-edge technology working in harmony. The significance of 3I Atlas cannot be overstated. It joins the legendary one, Oumuamua, discovered in 2017, and 2I Borisov found in 2019 as the only confirmed messengers from other star systems. What makes this discovery particularly groundbreaking is its massive size and unusual characteristics that are forcing scientists to reconsider their understanding of interstellar objects. Unlike typical asteroids or comets from our solar system, these visitors carry secrets from distant star systems, potentially harboring materials and information that could revolutionize our understanding of planetary formation, galactic evolution, and perhaps even the possibility of life beyond Earth. Each new interstellar detection brings us closer to understanding the true nature of our galaxy's wandering population. The discovery story. The incredible story of how we discovered this cosmic wanderer began in the final days of June 2025, when the Atlas telescope system at Rio Hurtado Observatory in Chile captured something extraordinary moving against the starfield. Larry Deneau, a key member of the Atlas survey team at the University of Hawaii, was conducting routine observations when the automated detection software flagged an unusual fast-moving object. The initial designation A11PL3Z was assigned to this mysterious visitor as astronomers worldwide scrambled to confirm its interstellar origin. John Tonry, the principal investigator of the Atlas project, immediately coordinated with observatories across the globe to track the object's trajectory and confirm its hyperbolic orbit. Within 48 hours of detection, follow-up observations revealed pre-discovery images dating back to June 14, 2025, indicating the object had been silently approaching our solar system for weeks. The challenge of detecting 3I Atlas stemmed from its path through the dense star fields near Sagittarius, where countless background stars made it nearly invisible against the crowded stellar backdrop. Once confirmed as an interstellar visitor, the Minor Planet Center officially designated it as 3Y Atlas, marking a historic moment in astronomy. This rapid confirmation process demonstrated the remarkable advancement in our ability to detect and track these rare cosmic messengers. A stranger in our midst. Alright, get ready to be amazed by the extraordinary characteristics that make 3I Atlas unlike any object we've ever studied in our solar system. This interstellar giant is racing through space at a mind-boggling 61 kilometers per second relative to our Sun, a velocity so extreme it actually proves the object originated from beyond our solar system's gravitational influence. Marco Michelli from the European Space Agency has determined that 3Y Atlas measures approximately 11.2 kilometers in diameter, making it significantly larger than both previous interstellar visitors combined. To put this massive scale in perspective, this cosmic wanderer is roughly the size of a small city, totally dwarfing the mysterious Oumuamua, which measured only about 400 meters in length. Daryl Seligman from Michigan State University pointed out that the object's brightness and size make it an unprecedented target for detailed scientific study. Unlike typical solar system objects that follow predictable elliptical orbits around the Sun, 3I Atlas follows a hyperbolic trajectory that will carry it back into the depths of interstellar space. The comet has developed a spectacular 25,000-kilometer-long tail as solar radiation heats its ancient ices, creating a magnificent display visible through powerful telescopes. This combination of extreme size, speed, and activity makes 3I Atlas a once-in-a-lifetime opportunity for astronomical research. The predecessors. To understand the true significance of 3I Atlas, we really need to look back at the groundbreaking discoveries that paved the way for this moment. The very first interstellar visitor, 1I Oumuamua, was discovered on October 19, 2017 by Robert Warwick using the Pan-STARRS 1 telescope in Hawaii. This cigar-shaped object, measuring roughly 400 meters long, totally baffled scientists with its unusual tumbling motion and mysterious acceleration that couldn't be explained by gravitational forces alone. Avi Loeb from Harvard University famously proposed that Oumuamua might be artificial in origin, sparking some pretty intense debate in the scientific community. 2 years later, amateur astronomer Gennady Borisov discovered 2Y Borisov on August 30, 2019 from his observatory in Crimea. Unlike the enigmatic Oumuamua, Borisov behaved like a typical comet, developing a coma and tail as it approached the Sun. Alan Fitzsimmons from Queen's University Belfast led extensive spectroscopic studies that revealed Borisov's composition was remarkably similar to comets in our own solar system. These discoveries established that interstellar objects come in different varieties, some mysterious and unusual like Oumuamua, others more familiar like Borisov. The cosmic journey. So let's follow the incredible path this ancient wanderer will take as it sweeps through our solar system over the coming months. Davide Farnocchia from NASA's Jet Propulsion Laboratory has precisely calculated that 3Y Atlas will reach its closest approach to the Sun, called perihelion, on October 29, 2025 at exactly 11:41 Universal Time. At this critical moment, the comet will be positioned 1.36 astronomical units from the Sun, about 203 million kilometers away, perfectly situated between the orbits of Earth and Mars for optimal observation conditions. This cosmic dance includes several remarkable planetary encounters that provide unique scientific opportunities. On October 3, 2025, the comet will pass just 0.19 astronomical units from Mars, only 28 million kilometers away, potentially allowing Mars-based instruments to conduct unprecedented close-range observations. Following its solar encounter, 3Y Atlas will swing past Venus on November 3, 2025 at a distance of 0.65 astronomical units before beginning its journey back to interstellar space. Earth remains completely safe throughout this celestial ballet, with the closest approach occurring on December 19, 2025 at a comfortable distance of 1.8 astronomical units, or about 270 million kilometers. This trajectory provides astronomers with multiple observation windows and vantage points throughout the solar system, maximizing scientific opportunities. A scientific gold mine. The arrival of 3I/Atlas represents, honestly, an unprecedented scientific opportunity that has mobilized the global astronomical community like never before. Karen Meach from the University of Hawaii is leading an international consortium of researchers conducting comprehensive studies of the comet's composition, structure, and behavior. The James Webb Space Telescope, under observations coordinated by Stephanie Milam from NASA Goddard Space Flight Center, has been scheduled to conduct detailed infrared spectroscopy to identify complex organic molecules within the comet's nucleus. Alan Fitzsimmons from Queen's University Belfast has already detected unusual isotopic ratios in the comet's gas emissions using the Gemini Observatory, suggesting formation conditions vastly different from our local environment. Ground-based facilities including the Very Large Telescope in Chile and the Keck Observatory in Hawaii are providing continuous monitoring of brightness changes and spectral evolution. Bin Yang from the European Southern Observatory has identified traces of exotic water vapor with unusual deuterium concentrations, indicating the comet formed in an extremely cold environment around a different type of star. This coordinated global campaign represents the most comprehensive study of an interstellar object ever conducted, with data collection providing insights into star formation processes, planetary system evolution, and the distribution of life-building molecules throughout our galaxy for decades to come. Unanswered questions. Despite intensive observations, 3I/Atlas continues to harbor profound mysteries that challenge our understanding of interstellar objects and their origins. Quanji Ye from the University of Maryland has been tracking unexpected brightness variations that just don't match typical cometary behavior, suggesting the object may have an unusual internal structure or composition. The comet's reddish coloration, observed by multiple telescopes worldwide, indicates the presence of organic compounds, but the exact nature of these materials, well, it remains unknown. Matthew Knight from the Naval Research Laboratory has noted that high-resolution Hubble Space Telescope images reveal intricate details in the coma structure that don't conform to standard comet models. One of the most perplexing aspects is the object's estimated age of 7 billion years, older than our entire solar system, which really raises questions about how such ancient materials have remained preserved during eons of cosmic radiation exposure. Tony Farnham from the University of Maryland has documented irregular outgassing patterns that suggest complex subsurface processes we honestly don't fully understand. The Discovery team, led by Daryl Seligman, acknowledges that many fundamental questions remain unanswered. What star system did it originate from? What caused its ejection into interstellar space? And perhaps most intriguingly, could there be more to this object than meets the eye? These mysteries ensure that 3I/Atlas will remain a subject of intense scientific scrutiny. The alien question. Here's where the discussion takes a fascinating and honestly controversial turn that has divided the scientific community. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University and former chair of the Astronomy Department, has gained international attention for suggesting that some interstellar objects might be artificial in origin. Following his controversial proposals about Oumuamua, Loeb has expressed interest in 3I/Atlas, noting that its unusual characteristics warrant careful investigation of all possibilities, including artificial origins. Sarah Seeger from MIT has emphasized the importance of maintaining scientific rigor while remaining open to extraordinary possibilities, stating that we must examine every aspect of these rare visitors. The Galileo project, led by Loeb at Harvard, represents a systematic scientific approach to searching for evidence of extraterrestrial technology in our solar system. However, most mainstream astronomers, including Paul Chodas from NASA's Center for Near-Earth Object Studies, maintain that natural explanations can account for the observed properties of interstellar objects. Robert Warwick, discoverer of Oumuamua, has consistently argued that these objects, while unusual, fall within the expected range of natural cosmic phenomena. The debate really highlights the importance of maintaining scientific skepticism while remaining open to paradigm-shifting discoveries. Dawn of a new era. The discovery of 3I Atlas signals the beginning of a revolutionary era in astronomy, where interstellar objects will become regular subjects of scientific study, rather than once-in-a-lifetime discoveries. Mark Norris from the University of Central Lancashire predicts that advancing technology will soon make these detections routine, fundamentally changing how we study galactic dynamics and planetary system formation. The Vera Rubin Observatory, which began full operations in 2025, is expected to revolutionize interstellar object discovery with its ability to scan the entire visible sky every few nights using advanced LSST camera technology. Michelle Bannister from the University of Canterbury estimates that within the next decade, we'll have discovered dozens of these cosmic wanderers, providing statistical samples large enough to understand their origins and distribution throughout the galaxy. Robert Yadika from the University of Hawaii calculates that the improved Atlas survey system, now operating telescopes in Hawaii, Chile, and South Africa, will detect several interstellar objects annually. This technological revolution means that each new discovery will add pieces to the cosmic puzzle of how materials, and potentially life itself, are distributed throughout our galaxy. The age of interstellar archaeology has officially begun, promising to unlock secrets about distant worlds and the formation of our cosmic neighborhood that have remained hidden for billions of years. From its mysterious origins billions of years ago to its spectacular journey through our solar system, 3I Atlas has challenged everything we thought we knew about interstellar visitors. Whether it's a natural cosmic wanderer or something more extraordinary remains to be discovered. As this ancient traveler continues its path back to the stars, it leaves behind more questions than answers, and opens our minds to possibilities we're only beginning to imagine. Like, share and subscribe to InnoVision Tech for more incredible discoveries from the cosmos.